Okay, today we're talking about polygons. Okay, we've talked about a couple different polygons, triangles and quadrilaterals. Okay, polygons is just the very basic. It's a simple closed figure formed by three or more line segments called sides. That's why triangles and quadrilaterals are included. Okay, you need to know the definition of polygon because it's going to ask you, it's going to give you shapes and say, is this a polygon? Okay, and you have to check, does it fit this definition? It's a simple closed figure formed by three or more line segments. Okay. If it's not, if it doesn't fit this description right here, then it's not a polygon. Alright? Alright, you need to write this down. Okay, triangle is 3 sides, quadrilateral 4 sides, pentagon's 5, hexagon 6, heptagon 7, octagon 8. On page 617, it lists a few more. Okay, nonagon is 9, decagon is 10. Okay. After that, they really don't have a name for them. Instead, what they do is they name them based on the number of sides. So, a 15-sided figure, they just call it 15gon. Okay. A 20-sided figure, they call 20gon. All right. But these are the common ones they're going to use. All right. You need to write this. So, it's going to ask you, is this a polygon? So, let's look at this first one. Okay. Is this a polygon? Does this fit the definition of a polygon? Yes. It does. It's a simple closed figure, 3 more line segments, so this is yes. If it's yes, then you got to classify it. What do we classify this as? Okay. It is a heptagon. It has 7 sides, so it's a heptagon. What about this next one? This bow tie shaped thing. Is this a polygon? No. Okay. Well, you gotta go through. You gotta go through your definition. Is it a simple closed figure? Okay, would you say this is simple? It's got kind of 2 figures, doesn't it? Okay. Which part of the definition is that it's formed by 3 or more line segments. The line segments can't cross. Do the line segments cross here? Yes. Yes, they do. So this is no. You have to explain. Read the directions. Okay, it says explain. It's because the sides overlap. Okay, the line segments they only intersect at one point. They don't intersect twice. So here the sides overlap. You'd be wrong. What about this next figure? Is this polygon? No. No, why? It's not closed. The definition is a simple closed figure that's not closed. It is not closed. Good. Alright, write this down. Alright, if you need to know the sum of the degree measures, this is the formula you need to use. It doesn't matter what polygon it is if it's a polygon, you can find the sum of the degree measures. And the formula here is n minus 2 times 180. The n would obviously be the number of sides that polygon has. Alright. If you ever are given a formula, something like this, and want to check it, make sure, test it with things you already know. We know what the sum of measures of a triangle is, isn't it? Don't we? What is a triangle? What does the triangle add up to? 180. Could we plug 3 in here and see if it works? What's 3 minus 2? What's 1 times 180? So it works for a triangle. Right? What about quadrilateral? We learned yesterday quadrilateral adds up to what? Right? How many sides does a quadrilateral have? 4. Plug 4 in here. 4 minus 2 is? 2 times 180 is? Right? So if it works for what we know, it probably works for what we don't know. So here, find the sum of the measures of a nonagon. How many sides does a nonagon have? 9. So we plug it into the formula. 9 minus 2 times 180. Now last hour I had students leaving off the parentheses here and just doing 9 minus 2. And then they were confused because a couple students wanted to times 180 by 2 first. That's not what you do. You work out what's inside parentheses first, which 9 minus 2 is 7. And then you take 7 times 180. And you get what? Anyone know? Good, it's 1260. Good, class. There's your answer. 13 gone. 13 sides, so we take 13 minus 2 because our formula is n minus 2. We times that by 180. The formula says times by 180. So 11 times 180 gives you
1980.
1980. Right? And that's how many degrees is in a 13-gon. Good. All right. Write this down. All right, so it says identify the polygon given the sum of the interior angle measures. So it tells you the number, you have to find what the polygon is, the name of it. Okay? So what we do is we work n minus 2 times 180 backwards. Okay? We set n minus 2 times 180 equal to the sum of the measures, 1440. All right? And then we just work it backwards. The first thing I need to do is divide by 180. So I take 1440 divided by 180, which is what? Now you get 8 here. So n minus 2 equals 8. So I add 2 to both sides. N must be 10, okay, which is a decagon. Decagon. Let's do one more. 4140. So n minus 2 times 180 equal 4140. Divide both sides by 180. 4140 divided by 180 gives you 23. So n minus 2 equals 23. Got to add 2 to both sides. Right. So here it's a 25-gon. Find the measure of one interior angle of a hexagon. Now, something I didn't mention is talk about regular polygons. Regular polygons are where the sides, all the sides are congruent and all that angle measures are the same. Okay. Like if you look at a soccer ball, it has 12 regular pentagons and 20 regular hexagons. All the sizes, all the shapes are the same. Okay, all the pentagons are exactly the same. Like the sides are the same, the angles are the same. Okay, so if a regular hexagon, if I want to know what one of the regular hexagon angles are, okay, then we do just like we've been doing. We find the measure of the sum of the measures of the angles of a hexagon. How do I find the sum of the measures of a hexagon? What formula do we just learn? N minus 2 times 180. How many sides does a hexagon have? So 6 minus 2 times that with 180. All right? And I find that 4 times 180 is equal to 720. So a regular hexagon has sum of the measures of 720. But how do I find out what one of those angle measures are? If they're all the same, how do I find out what one of them is? Yes, Kurt?
Divide by 6.
I divide by the number of sides. I take 720 divided by 6, right? And I find that each one of them is 120 degrees. Good. All right, find the measures of one interior angle of a pentagon. Pentagon has 5 sides, so I do 5 minus 2. I times that with 180. 3 times 180 is 540. And then I divide by the number of sides. 3 is not the number of sides of a pentagon. What's the number of sides of a pentagon? 5. Or really you could say the number of angles in a pentagon, which is the same as the number of sides. 5 sides, 5 angles. Pentagon has 5, so I divide that by 5. Right? I get 108. Your homework assignment for today.